Hello, everybody. This is Mrs. Snook with section 5.1, which is on rate of change and slope. And our objectives are to find the rate of change from tables and to find slope. So before we get started, I want to talk a little bit about what chapter 5 is about. And it's about graphing lines and writing equations of lines. And there are several ways that we can express information. In this picture here, we're showing information in a table. And what it has is 4 poles A, B, C, and D. And each pole has a distance that it goes horizontally, and then a distance it goes vertically. And you're asked to choose which 2 poles is the cable's path the steepest. And how do you know? And so we have the information here presented in a table. It can also be helpful if we can draw a picture of this data. And if we did that, that would be called a graph. And then oftentimes we want to be able to make predictions, given the data that you have, what happens if you add another pole. And so then we like to be able to have an equation, which would describe what's in the graph. So equation describes your graph describes your table. And so we have, my point is we've got 3 different ways here to show information. And in chapter 5, we're going to focus on graphing the lines and writing the equations of the lines. So the first thing we're going to look at is what's called rate of change using a table. Now, rate of change means how much does each line of the table change? So our first one is we have a marching band, and this marching band is marching different distances over time. So in the first minute, the band moved 250 feet, and in the second minute, it moved 520 feet. So the rate of change between the first and the second minute would be your 520 minus 260, that's how many feet it moved, over 2 minus 1, and the 2 minus 1 is how much time passed. We ended at 2 minutes and started at 1 minute. And so if you grab your calculators, you can actually punch this in, and what you get is 260 feet over 1 minute. So then the rate of change for that first minute is 260 feet per minute. Now let's see if the rate of change is the same from the second to the third minute. So second to the third minute, I have 780 minus 520 over 3 minus 2. Punch this in your calculator. And again, 260 over 1, or 260 feet per minute. Now let's check the last minute from 3 to 4 minutes. So I have 1,040 minus 780 over 4 minus 3. So do 1,040 minus 780, and I get 260. So again, 260 feet per minute. So the answer to the question, is the rate of change in distance with respect to time constant? The answer is yes, because every minute it was 260 feet per minute. Now, closely related to that idea of rate of change is the slope of a graph. Now, slope, we use the symbol M, meaning slope. And slope is defined as rise over run. So rise is how far up or down you go from one point to the next. And then run is how far left and right. So an up or a down is your rise. and a left or a right is your run. So looking at these graphs, we're going to do rise over run, and we can do that simply by counting boxes. So my slope in graph A is going to be, so I'm starting at this point, which is -2, -1, and I'm ending at this point, 1, 1. And if you see the red arrow, that's going up 2 units, so my rise is 2. So put 2 in for rise. It's going up, so that's a +2. And then we're going to the right 1, 2, 3 units with the blue arrow. And moving to the right is in the positive direction. So our slope is 2/3. Notice the slope overall is positive. And looking at the graph from right to left, it looks like it's going uphill. So if you think of uphill as a positive slope, that's one easy way to remember it. Now let's look at our second graph, graph B. This time, when we do slope, which equals rise over run, starting at our first point, which is -3, 2, and ending at our second point, 2, -2, my rise is actually going down 4 units. I can count down 4 boxes. 1, 2, 3, 4. Because it's going down, that's going to be a negative. So -4 is our rise. And then the run is right 5 units. 1, 2, 3, 4, 5. And because that's going to the right, that's in the positive direction. So I'm going to put a +5. And so that means the slope for this line is negative. And when you look at the picture of the line, it's going downhill. So positive is uphill, negative is downhill. We can do a little bit more practice with this. I'm going to pick 2 points, and you have to know their coordinates. So my point here at the top is at x is 2, y is 3, and my point here at the bottom is x is -3, and then y is +1. And again, we're going to do rise over run. But I want you to notice something. I can count boxes, or I can use the coordinates. So my y coordinate starts at 1 and it ends at 3. So then my rise, starting at 1, ending at 3, is going up 2. So I can do 3 minus 1. The second y minus the first y. I can do the same thing with the run. The second x, which is 2, minus the first x, which is a -3. And when I subtract a negative, I get a plus. So I'm going to do a 2 plus 3. So then slope is going to be 2/5. So I'm fine on these pictures if you want to count boxes or if you want to calculate using coordinates. Part 3. So what if I don't give you a graph at all? So you can't count boxes. That leaves you only one choice, and that is to use the coordinates. And there is a formula that you can use, which is slope equals y2 minus y1. That's your change in your y, or your rise, over x2 minus x1. And that's the change in your x's, or the run. And so then what I'm going to do is I'm just going to look at my 2 points. I have -1, 0, and I'm going to label them x1 and y1 and x2 and y2. So here's x1, here's y1, x2, y2. So now that I've designated which point is which, all I have to do is plug into my formula. So y2 minus y1 is negative 2 minus 0. x2 minus x1 is 3 minus a negative 1, so I make that a plus. I get a negative 2 over 4. Please reduce this to negative 1/2. Can also play the same game on this next one. It doesn't matter which point is point 1 and which one is point 2. So just for fun, I'm going to call this one x2 and this one y2. This one is x1 and this one is y1. Because it doesn't matter. As long as I'm consistent, I can do this however I want. So now I'm going to do y2 minus y1, which is 3 minus a negative 1 over 1 minus 4. And I'm going to get a positive 4 over a negative 3. And so then my slope is just a negative 4/3. So that's when you have lines that are slanted. But what do you do if you're trying to find the slope of a horizontal line or a vertical line? And just as a way to remember it, horizontal, think about when you're at the beach and you look out across the water and you can see the horizon off in the distance. And that horizon runs side to side. So horizontal is like the horizon. It runs side to side. Vertical is the other one, which is going to run up and down. So if I look at my line in picture A, it's running side to side. So this is horizontal. And if I use the formula for calculating the slope of this horizontal line, I'm going to call this one x1, y1, this one x2, and y2. Something interesting happens. So I want you to see what happens. I'm going to do y2 minus y1, which is 2 minus 2, over x2 minus x1, which is 2 minus a negative 3, or 2 plus 3. I get a 0 over 5. Put that in your calculator. Do 0 divided by 5. And what you're going to find is that m equals 0. And that is true all the time, every time for a horizontal line. All horizontal lines have a slope of 0. Now let's see what happens with a vertical line. If I do slope again, and I'm going to call this one x1, y1, here's x2, here's y2. I'm going to plug it into the same equation, y2 minus y1, negative 2 minus 1, over x2 minus x1, negative 2, minus a negative 2 means a plus 2, and so what I get is a negative 3 over 0. Plug that into your calculator. Do negative 3 divided by 0. And when you do, you should get an error. And in math world, we call that undefined. You cannot divide by 0. And so with every vertical line, your slope is going to be undefined all the time, every time. So now let's take a look at some slopes. And I'm not telling you if the lines are horizontal or vertical. I'm just giving you the coordinates. So don't worry about it. Just calculate the slope like you would do. So y2 minus y1 over x2 minus x1. So now you get to decide which one is point 1 and which one is point 2. I usually do the first point as point 1, so there's x1 and y1, and point 2 is x2 and y2. And then just plug in. So y2 minus y1, 2 minus a negative 3 is the same thing as 2 plus 3. And then I have a 4 minus 4. I get a 5 over 0. That is undefined, which means that this would be a vertical line. Let's do the other one. I'm going to do slope equals, let's go ahead and write the equation. If you write your formulas, every time you do these problems, in no time you'll have it memorized. And then x1, y1, x2, y2. So just plug in -3 minus a -3 is the same thing as 3 plus 3. And then I have 5 minus a -1, or 5 plus 1. I get a 0 over 6. Anything where 0 is in your numerator, so 0 over anything, that always equals 0. So then this would be horizontal. If you're ever not sure, just get a piece of graph paper and graph your points. And then you'll be able to see from the picture if you have a horizontal or vertical line. The last thing I want to show you is just a summary of what we've done. Line with positive slope slants upward from left to right. And in Snook World, I call that uphill. If it's a negative slope, it's going downhill. Now check this out. If you imagine a slope as actually a hill, maybe one out in your yard or on your street, and you're walking uphill, the steeper that hill gets, the bigger your slope is. What happens if it's flat? Well, if it's flat, it's horizontal. And it's not steep at all. So then your slope is 0. So that's an easy way to remember that. Think of slope as how steep the line is. And then if it is so steep that it's undefined, that's going vertical. Can you imagine trying to climb up this? So here's you trying to climb, and that doesn't work. You've got nothing that you're going to be able to grab onto. So that one is undefined because you can't do it. And in Math World, we say you can't divide by 0. All right, that's it for today, everyone. Thank you for watching, and have yourself a fantastic day.